In this lesson, we'll learn about reciprocal functions, which are used to model situations in real life where one of the variable varies inversely in relation to the other variable. Let's first define the reciprocal of a number. If we want to define reciprocal of a number, reciprocal of a number is time the given number, answer is equal to 1. The examples are, example is like 2 times 1 by 2 is equal to 1. So here 2 and 1 by 2 are called reciprocals of each other, are called reciprocal numbers. And similarly, if the given number is a, then what would be the reciprocal of a? So if given number is equal to 1 over a, then what would be reciprocal of the number? Reciprocal of the number is equal to a, because if we multiply 1 over a with a, the answer would be equal to 1, because 1 over a times a is equal to 1. Now, based on this concept, we will define reciprocal of a function. So for the given function f of x, so reciprocal of a function, f of x is 1 over f of x. So this is how we define the reciprocal of a function. Now, the task at hand is that we will first define the function y is equal to x, and we will draw its graph, and then we will draw the graph of its reciprocal function y is equal to 1 over x. So let's get started with the table of values. For example, let's first sketch the graph of y is equal to x, and then we'll sketch graph of its reciprocal function. Then we will sketch graph of its reciprocal function, f of x, reciprocal function y is equal to 1 over x, because x times 1 over x will be equal to 1. So for this, we are going to first define the table of values. So table of values for table of values. Let's assume that x has values like -10, -5, -2, -1, -1 by 2, -1 by 5, 1 by 10, 0. And similarly, now it continues to increase, like -1 by 10, -1 by 5, -1 by 2. Oh, these are plus values on the positive side. So these are 1, and then 2, 5, and 10. If these are the values for x, then what would be the values for the function y is equal to x? Obviously, whatever is the value of x, that will be the value for y. So this will be -10, -5, -2, -1, -1 by 2, -1 by 5, -1 by 10, and this would be 0. And similarly, we'll have this value as 1 by 10, 1 over 5, 1 over 2, 1, 2, 5, and 10. So if these are the values for x and y, it's not hard to plot these values, because we can easily sketch the graph from this is point 1, 1, 2, 2, and this is, we know that this is the graph of identity function y is equal to x, and we can draw the graph by just drawing the line through these points. And this is the line y is equal to x. Although we have many points here on the line just around the origin from the table of values, but that's what the graph of the line y is equal to x would be. Now if we want to draw the graph of its reciprocal function y is equal to 1 over x, so 1 over x will be y is equal to 1 over x, those values against the same values of x minus 1 over 10. When reciprocated, it will become minus 1 over 10. And minus 5 will become minus 1 over 5. Minus 2 will become minus 1 over 2. Minus 1 and minus 2. Minus 5. Minus 10. Minus 10, and there is no definition of 1 over 0 because it's infinite. And for plus 1 over 10, it is 10, and here it is 5, here it is 2, and here it is 1. So if we plot these values, what we have is there is no point corresponding to x is equal to 0. But for minus 10, there is a point minus 1 by 10. Means, so here minus 1, minus 2, minus 3, minus 4, minus 5, and 1, 2, 3, 4, 5. Here this is minus 1 by 10 is very, very close to this line, minus 1 by 10. And similarly, as we go to minus 5, it becomes minus 1 by 5. It's little away from, but not much difference. And similarly, for minus 2, it is minus 1 by 2. For minus 2, it's minus 1 by 2 is right here. And now, as we get closer, minus 1, there is minus 1. So this point is minus 1. Minus 1 is this point here. And again, minus 1 by 2, it's minus 2. Minus 1 by 2, it's minus 2. So the point is right here. and again when we go from -1 by 5, it will become -5. So as we are getting closer to origin, -3, -4, -5. So as we are getting closer to the origin for the value of x, the value of y is just drifting away from x-axis. So similarly, if we continue to do this, this will become like when it becomes -1 by 10, it will become -10. So -1 by 10 is very close to origin. So this is where we end up. So the graph of the function on this side becomes like, if we join these points in the freehand, this graph will look like this. It continues to get closer and closer to y-axis, but it doesn't touch and it doesn't cross y-axis. So this is the graph of, and similarly for our positive side, you can see that the graph passes through the point 1, 1, and otherwise this graph is like this, and at 1, 1 it touches and it just starts going along x-axis on the plus side, but it does not touch and it doesn't cross. This graph is y is equal to 1 over x. It has two parts. One part of the graph is in the first quadrant, and second part of the graph for negative values of x is in the third quadrant. So now you can make few observations here. Observations. That number 1, the first observation is that y is equal to x. Y is equal to x and y is equal to -x are two lines of symmetry. Are two lines of symmetry for the graph y is equal to 1 over x. Means that the graph is similar shape on either side of y is equal to x. It's also symmetric about this line as well, because the shape of the graph on both sides of this line is also same. So let's draw this line here, and equation for this line is y is equal to -x. So these are the two lines of symmetry, and as you can see that the point 1, 1, this point 1, 1, and this point -1, -1 are two points which are common to both the graph y is equal to x and y is equal to 1 over x. So that is our second observation. Observation 2 is and these points which are on both sides or on both graphs are called invariant points. The points 1, 1 and -1, -1, because if you look at the table of values, they are on both sides. Y is equal to x. Under y is equal to x, we have -1 here and we have -1 here as well. Similarly, we have 1 here and we have 1 here as well. Therefore, 1, 1 and -1, -1 are both invariant points. are invariant points. But there is one more thing that we observe is observation 3. A line which goes a long way along the graph but does not touch or cross, but does not touch or cross the graph is called asymptote, or cross the graph is called asymptote. So here you can see that both x-axis and y-axis are asymptotes. So here x-axis, and what is the equation for x-axis? The equation for x-axis is y is equal to 0, is asymptote to the graph of y is equal to x, 1 over x. And similarly, the y-axis for which the equation is x equal to 0 is another asymptote, which means this y-axis just stays along the side of along the graph. It doesn't cross the graph, or it doesn't even touch the graph. So both x-axis and y-axis are asymptotes. The long run behavior. So observation 3. Observation 4. Observation 4 is the long run behavior is when x becomes very, very large. Long run behavior is when x becomes infinity, means very, very large. What happens to y? Y becomes very, very small for long run behavior for 1 over x, means for the reciprocal function. So when x becomes very, very large, y becomes very, very small. As x starts getting bigger and bigger, y starts getting smaller and smaller. And when x approaches to minus infinity, similarly, again y becomes closer to 0. This is long-term behavior or long-run behavior. And observation 5. Observation 5, that is also called short-term behavior, short-run behavior, means for, of course, for reciprocal function we are saying for 1 over x, or for y is equal to 1 over x. This is if x becomes very small, when x approaches to 0, y plus infinity. And similarly, if x approaches to 0 from either side, y becomes either negative infinity or plus infinity. It depends if x is approaching to 0 from left side. So if we say 0 plus 0, then y approaches to plus infinity, and when x approaches to 0 minus 0, y approaches to minus infinity. Means x approaches to 0 from left side. And there is nothing more. If let's take a look if there was any other requirement. So we needed to describe long-run behavior, short-run behavior, domain, and range. So here for the reciprocal function, the domain is everything, but x equal to 0 is not included in it because it is not defined. So domain for y is equal to x is the entire set of real numbers, For y is equal to 1 over x, it is x where x belongs to R. Same thing, means entire set of real numbers, but x is not equal to 0. Means all other real numbers can be part of the domain except x equal to 0. Similarly, for range x, this means y, where y belongs to R, but y is okay here, and this is range, and same thing here, y is never equal to 0 for 1 over x. So here it will be y, where y belongs to R, but the y equal to 0 is not permitted, therefore we exclude that part here as well.